Gregor Arturo here, and I got something cool to share with you. At least I think it's cool. I hope you think it's cool, because this is cool. This is basically looking at a different perspective in terms of how to interpret the vortex number maps that we use to make Rodin coils. These guys here, the Rodin coils. Ha 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 ha. Alright? Now basically, these maps are either usually, what we've been working with, squares or rectangles. Okay? Either a 1-to-1 ratio or a 2-to-1 ratio. So a 1-to-1 would be like, simplest as a 9-by-9 matrix. So 81 possible numbers in this matrix, and we take basically the square and wrap it around itself to form these coils, and the numbers were basically laid out all around this. Well, I've been thinking differently about how to wrap them, because say the Rodin coil, when we actually do the 12-set weaving pattern, we aren't doing it. The maps that we've been using don't dictate how to actually make that coil. I don't know how the heck Marco came up with the 12-point coil, because the math, the way the maps are, don't connect like that at all. So, even though the concept's still there and it still works, the process of getting there has been wrong. And I figured it out. At least I think I figured it out. I'm presenting an argument. I don't want to call this an argument. Calling this an expansion of knowledge and understanding. So, let's take, we're going to take the 2x4, okay? There's 3 number maps we're using. A 1x4, a 2x4, and a 1x2. And what that basically means is, say this one right here, this is the 2x4, consists of 3 circuits. And the 3 circuits are your doubling, halving, and triple circuits. So you got doubling on top, which I'm calling your north magnetic pole energy, and your really doubling, halving can be flip-flopped. But let's say the doubling is your north, and then your trinity circuit in the middle, which is diamagnetic, the diamagnetic force, and then the bomb circuit, which is your south magnetic pole energy, which is your halving circuit. So these are your 3 circuits that I've been arguing for about the past couple weeks is the magnetic field, not the electric field, which everyone's been wiring. The electric field is perpendicular to the magnetic field, to the 3 numbers going up, down, up, down, up, down. And so what we're going to do is we're going to create the rest of the electric field, or connect the rest of the electric field, and technically the other 2 circuits there as well. And those other 2 circuits are what this means by a 2x4. One's counting by 2, so these are the diagonals. So let's see an obvious one. 8, 6, 4, or 4, 6, 8. That's counting by 2. So the opposing direction will be 4. So we got 4, 9, 5. And I can't remember where that is. It would be 4, 8, 3 would be the other direction. 4, 4. Besides that, so there's basically 4 patterns in this. There's 4 direct axes of patterns: the electric field, the magnetic field, and then these counting by 2s and 4s, which to me would have to maybe be the longitudinal fields and transverse fields working together. I don't know. I'm not going to throw anything out there. I haven't put my mind completely into saying that's what these are interpreted. But so let's show the magic of these new maps. All right. So if we take the numbers and we twist around them on themselves to spiral them to make just like a coil, we're spiraling the energy essentially. You can connect the maps to themselves. I'm going to show you how to do this. It's really simple. I recommend just going to Excel, type up these numbers. This is basically, a 3x6 repeated 5 times, so it's like 3x30. Just to do this yourself, you can easily do it. And so the 1 up here in the corner, we're going to have to connect the 1. So if I pull up my little book with the electric field oscillations, there's 18 for each of these sets. So the doubling, halving, trinity circuits are by 6, the electric field oscillations by 18, and then the other 2 are by 9, and 9. The 2 and 4 in this one. What's really important, this one, the electric field oscillation counts by 2. What's really important to think about that is if you take the electric field oscillation, because it's 18, and make every opposing step positive, negative, take the positives, take the negatives, they're both then put in sequential order right there, the counting by 2, one in reverse of the other. So you could say it's counting by 2 in one direction and 7 in the other direction, essentially, or positive charges and negative charges. They're switching place at the same time. Conventional theory usually would say electrons are moving one direction, the positive charges or electron holes are moving the other direction. I really think there might be some positive charges actually moving to create the self-magnetic pole energy. As Ed, our friend from Coral Castle, loves to talk about. So, let's go back into this. So we got the 1, and the 1 in the electric field oscillation borders a 9 and a 7. So it's already boring the 9, so it's going to be connecting to a 7. The first 7 on the bottom row is the 6th one, and so it's going to connect like so. And it's going to be able to keep connecting and wrapping around to form the magnetic field. Alright? The next 7 down the line, it can also connect to keep the same pattern going. It always just has to connect to a 7 if I'm going to be using that 1 to connect. What's important to understand here is it's the 6th one, or there's 5 unique circuits. And if it connects to the second 7, 5 plus 6, there would be 11 circuits. However, let's do the other side now. So let's connect the 8. The 8 borders the 9. So 2, 8, 9. So we're looking for a 2 for it to connect to. And the 2 is right next to it. So it's only going to wrap itself. It's so hard to do the 1 with these little guys. The 8 is going to wrap. I can do it. Promise. Absolutely promise. I can save the world. I can wrap some paper. Alright, we got the 8 and the 2 sort of wrapped. There we go. Boom, boom. And this creates a single circuit. A single circuit electric field oscillation. So we have 1 circuit and 5 circuits. If I want to connect to the next one, the next 4 is another 6 down the line. And so, boom. Is it 4? Yeah, it's 4. There we go. And I can connect to it too. And this one is going to be the, so it's the first circuit, 1, 2, 3, 4, 5, 6. So 7 circuits. Exactly. So there's 2 equations here with understanding the electric field oscillations. So these might be the first 2 equations I write. So the electric field can either be written as 6n minus 1 or 6n minus 5. There we go. There's the 2 parents. 6n minus 1 or 6n minus 5. This is the amount of circuits the electric field can exist when wrapping these type of toroids. It's actually the only way it can exist when wrapping this. It has to be basically based off the primes 1 and 5. So, I talked to you about the Star of David. This is my Star of David. I'm doing it with 6 circuits. Not 3, 6 circuits. And 6 circuits is the, if you use 3 circuits and wrapped it and did a 3-point star, you don't get the opposing triangles, which is the Star of David. You need 6 circuits to get the opposing triangles, which is 2 of each circuit, 2 doubling, 2 halving, and 2 trinity. And this wraps the exact same way. This is a 1x4 map, and so if I pull out my little book, we got the 1 in the top corner on a 2x4. No, a 1x4. So that means it counts by 1 one direction, so you can easily see that. We got 9, 8, 7, 6, 5. The other direction it's counting by 4. So the 1 in a 1x4 map is next to a 6 in itself. And so we see the 1, and it's already next to a 6. We're looking for that one, and it's the 5th circuit. Boom, 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 boom. I can't do it. There we go. So now it connects. Actually, this differs. We're learning right now in the process. I swear I did this with the Star of David. But this is connecting to the 4th circuit, or the 5th circuit. So that means there's only 4 circuits, electric circuits, in the Star of David. Or using a 2-set map. And so let's try the other direction. Let's learn right now on YouTube how this actually works. So this is a double circuit, or sort of 6 circuits. So the opposing one's 7. I swear I did this, but I'm guessing I didn't. Must have been high. 7. So we're on a 1x4. A 1x4 is 7. and a 1 by 4 borders a 9 and a 4. So he already has the 9s. We're looking for the 4. The 4 is the third one. So if I connect the 7 to a 4, this allows me to create 2 electric field circuits. Whoa! Look at all this variation. Okay, so we gotta keep going up if you want to keep exploring. So this is going to be the first iteration, and the second iteration is going to be 6n minus one's 4, 2. The other one is 6n minus 4. Ooh, there we go. So look at this. We're like building up history, not history, understanding of how this works right now with the help of YouTube. So we got 6n minus 1, 6n minus 5 for the first iteration with 3 circuits. The second iteration of circuits, we have 6n minus 2 and 6n minus 4. There's going to be a third iteration, a fourth iteration, and I say, hey, let's start playing, let's start going. Logical deduction would be that the next one would be, that was 4 and 2, maybe 3 and 6, I don't know. We'll see. But yeah, thanks for listening. I hope you learned something. I hope this isn't like completely too far out there. But yeah, basically what I did is I made all 3 number maps on these little piece of papers, and then I did one on a 6. So that's basically 6 circuits, and just wrapped around themselves. So if you did not understand what I'm saying, I just seem like I'm a babbling idiot talking numbers. Go into Excel, take the 3 number maps, and you can create them yourselves. If you haven't, make some graph paper and put out, 1, 2, 4, 8, 7, 5, 3, 3, 9, 6, 6, 9, and see how they interlock to create these patterns. And if you put them in Excel, print them out, cut them out, wrap them around yourself, there you go. That's all you gotta do. You gotta do it hands-on, play with the patterns yourself, and see the patterns yourself work firsthand. So that's really cool. I like where this is going, and I think I'm gonna sign off. Yeah, I'm signing off. I'm gonna wire my. This is a sneak preview. I'm about to wire my first very unique Tesla coil. And this guy is coated in magnetite. Ooh, this is gonna blow your mind when I hear about the actual way this is wiring, how it's going to fire, what exactly it does.